Hi, I think we can give it another minute and see if others are going to join before we start. Okay, I think it should be okay to begin the presentation. I just want to make sure that I'm audible. Can you all hear me? Uh, okay. Also, at any point, if there's any issue, if you're not able to see the presentation or if I'm not being audible, I would prefer if you would unmute yourself and speak up because while presenting, I may not be actively monitoring the chat. So even if you're typing any issues that you may be having, I might miss it. So please unmute yourself at any point if there's an issue. I'll be sharing the screen right now. Let me know if you can see it. Yeah, I'm trying to share it. Um, can you all see it? Please unmute yourself and let me know.
Yeah, we can.
Okay. Right. So, my name is Riyya. I work as a software engineer in the semiconductor industry. And today I'll be conducting a presentation on basics of C++ programming. I'll try and wrap the presentation within an hour. So that should be, I think 10 p.m. Eastern time for you. Yeah. So I'll try and wrap it up by then. Just to confirm, can you see the next slide where it says C++ and a set of bullet points?
Yeah.
Okay. So I'm not sure how many of you are familiar with C++, or even if you are, I'm not sure of the extent of your knowledge. So I'll be starting off from the basics. And this presentation is pretty much just about the basics of C++. Uh, and the assumption is that most of you are familiar with C programming. Even if you aren't, I don't think it's a very difficult. It would be a very difficult presentation to follow. So C++ is, it's a programming language that is platform dependent. By that I mean that it depends on the hardware of the system, as compared to a platform independent language like Java, which interacts with a module, JVM. So it doesn't really depend on the hardware, which means a file of a programming language that is platform independent can be ported from one kind of hardware to another, but that is not the case with a language like C++, which works very closely with the hardware. It was developed by a Danish computer scientist named Bjarne Stroustrup in 1979. Uh, it's an extension of C programming language in that just like C is a platform dependent programming language, so is C++, but it's a little more optimized than that. And because it depends on the platform, and because it's more optimized, it gives programmers a higher level of control over the system's resources and memory. Because when you talk about hardware, when you talk about platform dependence, memory is really important. That's how the whole programming and all works. And so C++ gives a greater deal of control over the memory as compared to C. So that is essentially one of the advantages of C++ over C, that it is more optimized. It gives a greater amount of control. And the reason for that is it supports object oriented programming. By that, I mean it can support objects and classes, which we would be discussing later in the presentation. And so it gives an advantage in terms of the performance, the speed, and security. So this is an example of C++ programming. The header is IOStream instead of stdio. I mean, that can also be used, but when we mainly talk about C++ programming, we use IOStream as the header file. Um, and then, you have two variables declared, A and B. Um the value for which would be input from would be obtained as an input from the user. So instead of saying printf or scanf that you actually see in C programming, you use cout and cin over here. Cout in order to print something. So it will say enter the value of A. And then you use cin to scan the value of A. And then B is computed as twice of that of A. And then you just print that again using cout. And then, your output is, as you can see, you have the user inputting a value of 10, and then uh, they get the double of A, which is 20, and then for 8 they get 16. So you can see that this isn't just a syntax difference, it's also an advantage, because when you actually use things like printf and scanf commands in C, you use %d, and then you use ampersand, because in C what you do is you just like C++, C also has memories, but you actually need to use things like %d and then ampersand to access the value using the address of the variable, whereas this is taken care of in C++. You just have to enter the value and print the value by using the name of the variable, and then the internal workings of the programming take care of it. So before we move on to the concepts of C++, I'll talk about the applications briefly. So as I mentioned, it's dependent on the hardware. It's a platform dependent language, and that's why it's used in operating systems and embedded systems programming. It's also used for game development as well as for graphical user interface or GUI development. These are the data types in C++. So the first is Boolean, which is pretty much like a true or false, and then it occupies 1 byte. Then you have char for those single characters like A, B, C, those single characters. So again, it'll just occupy 1 byte worth of storage. Then you have the integer values, basically the whole numbers. So that occupies 2 or 4 bytes. It's really just 4 bytes as of today. 2 bytes used to be the case back in the 1970s when we just had 16-bit compilers. But in 1985, we got the first 32-bit compiler, which is why integer variables started occupying 4 bytes instead of 2 bytes. So as of today, it's just 4 bytes. Then another data type is floating. So if you want to store fractional numbers which have decimals, you use a floating variable. So float and double are really just the same. They just have different sizes and they're used depending on the number of decimal digits. And then finally, you have strings, which are basically words um, that need to be stored, and then they they need about 24 bytes of storage. So next we have classes in C++. So class is also a user defined data type, and it optimizes the whole flow of the program, in that your code becomes a lot more optimized, and they have methods of functions and they have variables that belong to the class, and they're called class members. So this is an example of a C++ class. The syntax is that you start off with the word class followed by the name of the class. So in this case, the name of the class is mathematical operations. You declare a variable of integer type C, and then it has two functions, int addition and then int multiplication, meaning these two will return integer values. So for addition, you have two variables A and B, which are the parameters, the arguments that you're going to pass. And then you have a variable, and then you use C, which is computed as the sum of these two integers. And then you print that value. And for multiplication, C is computed as the product of the two variables, and and then you just print the value of C after that. So the next is object. An object is basically the instance of a class. So you have a class with all these attributes or members in the form of functions like addition and multiplication and variable like C. But you actually need something to you need something to access these members. So you do that by means of an object. So if I were to give an analogy, a car is basically an object, and it has attributes like weight and color, and then method such as driving and braking. So, in the previous example, this is your class named mathematical operations. So, in order to use its members, that is, its functions, you will declare an object named x, and you do that by writing the name of the class with a space and then the object. So x is the object over here. And then you do x dot function name. So addition in this case. And then function addition has two parameters a and b, which are of type integer. So after writing x dot addition over here, you will pass in the parameters like 2 and 3. You can do the same for the function multiplication by just passing the parameters, and then it'll give you the output that the sum is 5 and then the product is 20. So the next concept when it comes to classes is inheritance. So inheritance basically refers to the capability of a class to inherit or get the properties and characteristics of another class. So you have a base class, and then you have other classes that derive from it. That is, they they get its properties, its methods, and variables. So the new class is called the derived class or child class, whereas the existing one is called the base class or parent class. And so alternatively, the derived class is also called the subclass. And oh, there is a typo, I'll fix that. And then the base class is called the superclass. Now, the reason why we do inheritance is that we saw in the earlier example that you have a function like addition and a function like multiplication, where they need two parameters and arguments, and then they return the answer for that depending on what the function is supposed to do. So addition will return the sum of the variables, and then multiplication will return the product. Now, even though this is a very basic example, this is something that you can see being used in multiple cases. And so you don't really want to you don't really want to create multiple classes, and then you don't want to repeat the same code again and again. So that's the reason why we use inheritance. Because if there is a parent class, say A, which has properties of which has functions addition and multiplication, and then you have another class B that needs those exact functions in addition to some other functions like subtraction and division, we can have class B with just we can have a class B where we'll just define the subtraction and division functions, and it can actually inherit the addition and multiplication functions from A. So you don't have to rewrite that code. So it's a lot more efficient that way. Uh, to give another example, you can look at these different kinds of vehicles like bus, car, and truck. They have some things in common. They have a fuel amount, and they all have a capacity. Um, they all have brakes that need to be applied. The exact workings of those may be, the exact values of those may be a little different, but they have these requirements as such. So you can just have a parent class vehicle that has all these attributes and members, and then you can have different classes like bus, car, and truck inheriting from vehicle, so they all get access to these functions. So that's the reason why we use inheritance for optimization and efficiency. We'll not go too much in detail over this, but I'll just give a basic overview. So, when it comes to inheritance, it is done in three different ways. First is public inheritance. So, this means that the members are accessible from outside the class. So, if a function is declared as public within a class, it can be accessed from outside. Whereas in the case of private, it cannot be accessed. And for protected, it means that, that although the members cannot be accessed from outside the class, you can have a derived class inheriting from the parent class. So, so the derived class would end up having those same attributes as that of the parent class. So that's how the protected inheritance works, where it can't be accessed from outside, but the members can be accessed in inherited classes. So we'll talk about the types of inheritance next. So first is single inheritance. It's very simple. You have a base class or a parent class called class A. It has some functions and attributes, and then you have a class B which is inheriting only from a single class, that is class A in this case. So the way you declare it is this: you have class A, and then the body of class A would have all the functions and variables which are necessary for it. And then for the inheritance, you declare a class B with a colon, and then in place of access mode, you will specify what kind of access it has to class A, whether it's a private access, public access, or protected access. So you write class B colon public A, for example, for a case of public inheritance. So, as a result, Class B would have access to all the members of Class A, and then within Class B, you will define functions which are native only to Class B. So, that's how single inheritance works, because in this case, Class B is inheriting only from Class A. So next is multiple inheritance, where a class derives from multiple base classes. So, you may have a class A, for example, that has addition and subtraction functions. And then you have a class B, which has multiplication and division functions. And then you need a third class called class C that has all these four functions. So you can just have class C inheriting from A and B. So in that way, it will have access to all the four different functions, two from class A and then the two from class B. So you just declare the body of the first class and then the second class, and then for the third class, you declare it and then you specify the kind of inheritance it has from the two different classes. So if you have a class A inheriting from B and C, you write class A colon public B comma public C. So in the same line. And then of course you have the body of class A, which has functions in addition to the ones it inherited from B and C. Uh, then the third type is multi-level inheritance. So in this kind of inheritance, you have a derived class from another derived class. So for example, you have class C, which has its set of functions and variables. Then you have class B inheriting from class C. So and then you specify the kind of inheritance that is there, like public, private, or protected. So if class C has a function for addition and subtraction, class B ends up inheriting that, and then the body of class B would have a separate function, like class multiplication, for example. So class B has the multiplication function as well as the addition and subtraction function that it inherited from class C. And then you have class A, which publicly inherits from class B. So, or yeah, it inherits from class B. So, since class B has addition, subtraction, and multiplication, class A would end up having that as well, and then the body of class A would be something new. So the division function, for example. So that's how multi-level inheritance works. When you want to increase this, when you want to increase the scope of the classes, wherein you keep adding new functions, but you want to make sure that they have access to the previous ones as well. So that like previous functions or previous kinds of variables as well. So that's where you have that's when you create a multi-level inheritance for classes. So next is the hierarchical inheritance. So in this kind of an inheritance, you have a class that inherits from only one base class, but then it has multiple derived classes inheriting from it. So you can see that here you have uh, class D, for example, that's like a base class. And you have classes B and E inheriting from class D. Now you can see that class B is not really inheriting from any other class, it's just G. But then you have classes A and C, you have classes A and C inheriting from B. So in this kind of an inheritance, there is a hierarchy. So a class inherits from only one class, but then it has multiple classes inheriting from it. So same is the case with E. It inherits only from G, but then it has D and F inheriting from it. So finally, you have the hybrid inheritance. So in this, you have all the different kinds of inheritance combined. So, for example, you can look at class A and B. So, this is a case of single inheritance where class A is inheriting only from class B and no other class. Then you have multiple inheritance. You have class E, for example, which is inheriting from multiple classes like class F and class G. You have multi-level inheritance because you have class B inheriting from class F, and then you have class A inheriting from class B. And so class A ends up having properties from both class B as well as class F. And then you also have uh, the hierarchical inheritance, where class B is inheriting only from class F, but then it has multiple classes being derived from it, like class A and class C. So you can see there are so many different kinds of inheritance which are there, and that's why this is called a hybrid inheritance. So the kind of inheritance that you end up using in programming really depends a lot on how you are formulating that architecture, what kind of access you want a class to have. It's very difficult to say which one you should use. It really depends on a case by case basis. So if you want to if you want to define structure in a certain way, you'll have to look at what kind of access has to be given to which class, what kind of information it needs, and then you design the system architecture accordingly. So now we'll talk about a new concept called polymorphism. So poly means many and morphism means form. So as the word suggests, it means having different forms. It's basically the ability of a message to be displayed in multiple forms, or exhibiting different behavior in different situations. So there are two types of polymorphism. One first is a compile time polymorphism, and then the second is runtime polymorphism. So compile time polymorphism refers to the polymorphism that is achieved during compile time. Compile time is the compilation time by the compiler. Um, Whereas runtime polymorphism is the polymorphism that is achieved during runtime, that is during execution, when you actually have the program displaying its output, for example. So the compile time polymorphism is achieved by data members, whereas this cannot be done by runtime polymorphism. So an example of compile time polymorphism is function overloading or operator overloading. Whereas an example of runtime polymorphism is virtual function. So first we'll talk about compile time polymorphism and its examples. So the first is function overloading. So, if this is a case where you have multiple functions that have the same name but different parameters. It could be different number of parameters or different type of parameter. And in that case, the function is set to be overloaded. That's why you call it function overloading. So this can be function overloading can be done by change, like I mentioned, it can be done by changing the number of arguments or the type of arguments. So this is an example. Um, you have a class, and then you have a function called func. So you have void func, which has a parameter of type integer, so int x. So in this function, you're simply printing the value of that one function. And then you have another function which is again called void func, and then it has two parameters instead of one, int x and then int y. So in this case, it prints the value of both parameters. So you can see that here the function name is the same, but the number of parameters varies depending on whether it's the first one or the second one. And both of them are just printing the value of the parameters, but the print statement differs based on whether it's the top implementation or the bottom implementation. So within the main function, you declare the class as well as the object, and then when the object tries to access the function func, a func with only one parameter 7, it gives the following output: value of x is 7 in this case. Whereas when you have object 1.func with two parameters or two arguments being declared, 85 and 64, it will call upon this function, and then it'll have this print statement: value of x and y is 85, 64. So the function that the object or the program executes really depends on the number of parameters that you declare. So it's an integer in this case. This whole functionality can also be changed based on the kind of implementation you want. So for void func, you could have an integer declaration where it just returns the value of the variable, and then the second implementation could maybe have a floating variable where you return twice the value of the floating variable. So when you actually call upon the functions, it'll actually look at the number of argument as well as the type of argument before it decides which implementation of that function has to be executed. So if you put in an integer variable like 7, it will simply return the value. Whereas if you put the value of a floating variable, it will return twice of that value if that is the way you code it in the class. So basically this can be used. So this is the kind of example I can give. Let us say that you have area of a geometrical shape like a square or a circle. So you actually just need one variable, int x for example. So like int x or int y, so int x for example. So depending on so let's say that a square has sides of integer value, and then you have a circle with a radius that may have decimal, like the radius can be 2.5, and then the side of a square can be 3, that is an integer value. So you can have a function called area, which which can be overloaded. So when you overload it with an integer value, it will return the area of a square, that is side square. Whereas if you put a floating value, it'll actually return the area of a circle. So this is just one example in which you can actually differentiate and then decide how the function overloading works. So the next case of compile time polymorphism is operator overloading. So this is used to overload the operators. That is, plus, minus, the ones that are used for addition, subtraction operations. So this example that I'm about to discuss is it's a little bit complicated, but if you try programming it, it'll be a lot clearer. I'll just try to explain it as well as I can. But I can understand that this one might be a little difficult to understand over a presentation as opposed to actually coding it and seeing what happens. So you start off with a class name, like class complex, and then the implementation. It has two integer variables like real and imaginary. A function named complex, which has two parameters, int, uh, r and I. So the variable real gets assigned the value of r, and then the variable imaginary gets assigned the value of I. So real gets the first parameter, and then imag gets the second parameter. And then you have operator overloading over here, where you declare the operator, and then you have an object. Uh, Wait, I think I went to the next slide. Yeah. So this is how operator overloading works. You'll declare the class name, that is complex in this case, and then the name of the object, res. And so if this is an object, it will have access to the members of this class. The members being variables, real and imaginary. So for the object res, the real value of this object would be the sum of the value of the real variable, uh, plus the value of the real plus the value of the real variable of the object. Because as you can see, you have an object declared over here, an object which is an abstraction of the complex class. So this object ends up getting the value which is a sum of the real variable, this real variable, as well as the value of the value of the real variable of this object. And then the imaginary variable of this object would be the sum of the value of the imaginary variable, as well as the imaginary variable value of this object, and then it'll return this object. And then you have a void print function which ends up printing the values of the real variable as well as the imaginary variable. uh, Now notice that after printing out the value of the real variable, it's it's appending an I next to the imaginary, because here we're talking about real and imaginary numbers, complex numbers. So you'll just see that. So here, in the main function, you have two objects declared, C1 and C2. So for C1, 10 is the value of the real number, and then 5 is the value of the imaginary number. And for C2, 2 is the value of the real number, and 4 is the value of the imaginary number. So in order to ensure that the real values are added and the imaginary values are added, we use operator overloading. So you'll declare an object C3 which is equal to C1 plus C2. Now, now, C1 and C2 are actually complex variables, but this plus operator has been overloaded with this implementation. So, what will end up happening for C3 is that the real value of C3 would be a sum of the real value of these two objects, as you can see over here. So 10 and 2 get added and give you a 12. And then the imaginary value of C3 as defined over here would be the sum of the imaginary values of C1 and C2. So 5 and 4 in this case, which would give you a 9. And then when you call upon the print function, it'll just end up printing the real and imaginary values. But before printing the imaginary value, it will append that with an I. So you end up getting 12 plus I9. So that's how operator overloading works. I know that this thing might be a little difficult to grasp over presentation, but you can try coding it, and then it'll make a lot more sense that way. Because addition or plus has been overloaded with this implementation instead of a simple addition. So that's why it's called operator overloading. So next is runtime polymorphism. This is, as I mentioned, this is the kind of polymorphism that is seen during runtime. So an example of this would be function overriding. And function overriding is what happens when you have a derived class that has a definition for one of the member functions of the base class. And so that function is set to be overridden. So if you have a base class with a set implementation for a function, say function ABC, where ABC is the name of the function, and you have function abc in a class A, that is the parent class, and then you have class B deriving from class A, which means it should have access to function abc and its definition. But then it ends up having an entirely new implementation for the function abc. So in that case, function abc is set to be overridden. So this is an example of that. You have the base class, and then you have a function called print. So this function would basically just end up printing base function. That's it. Those two words. And then you have class derived, which publicly inherits from class base, which means it would have access to the print function. But then you actually see a print function over here, and it prints derived function. So void print or the print function in this case is set to be overridden because class derived is inheriting from class base, and then it's altering the implementation of the print function. So that is an example of function overriding. So in the main function, if you declare the class name derived followed by the object names like derived one and derived two, and then if you call upon the print function from derived one object, it'll access this function. And so it would end up printing derived function, as you can see over here. But then here, this is what is, but then here you have derived to object that is trying to access the print function of the base class. So it'll end up printing this output, that is base function. So that's how it works. So virtual function is basically a function that is declared in the base class using the keyword virtual, and then it is redefined or overridden in in the derived class. So for this, you need to use the virtual keyword inside the base class and declare it within the base class, and then you derive it in a child class. And because this is an example of runtime polymorphism, it happens only during the runtime. So here, for example, you have class base. So here you're declaring a print function that which is a virtual function. So you'll start off by writing the keyword virtual, and then you will define the type of function, whether it's a void function or whether it's an integer value returning function or whatever it is. So you'll start off by saying virtual and then void print, for example. And then you have void show, which is not a virtual function. So that's just a normal function. So void print would print base class, and then void show would simply say show base class. So that's what you have for the for the base class. And then you have the derived class that is publicly inheriting from base class, meaning it would have access to these members. And so as you can see, void print is a virtual function. And then you have another void print function over here, uh, with a different definition. So it says print derived class. And then you have void show function as well, show function as well, which is being overridden with a new definition because it'll print show derived class instead of show base class. So, in both these functions, both of them are being overridden in the derived class. The only difference is that print is supposed to be a virtual function. So when you go to the main program, you declare you declare a base pointer for the base class, and then you have a D object for the derived class, and then you end up passing the address of D to the base pointer. And then you have base pointer access the print function as well as the show function. So for the out for the output, it prints print derived class, but then show base class. The reason for that is base pointer actually has the address of the object of the derived class. So when it tries to access the print class is actually a virtual function. Now, a virtual function is declared in the base class, but it's defined only in the derived class, which means that the definition in the in the derived class is what would actually be implemented. So even though base it's a base pointer, it would end up printing the definition of the derived class. Whereas when it tries to access the show function is not a virtual function, so it'll end up having the same implementation as that of the base class. So it'll print show base class. Again, this is another confusing concept which cannot be easily understood over representation. This is something that you can make sense of only while you're programming things. But I think as long as you remember the key concept that a virtual function is declared in the base class but defined in the derived class, you should be good. I think that is good enough information. So yeah, that is virtual function, and then that is an example of runtime polymorphism. So now I'll be talking about the last two concepts of this presentation: call by value versus call by reference. So let me actually show you the example, and then of both call by value as well as call by reference, and then I'll explain what the difference between them is. So this is an example of call by value. So you have a function void swap with variables int x and int y. So as the name suggests, the idea of this is to swap the values of the two variables. So if x is 2 and then y is 3, I would like x to have 3 and then and I would like y to have the value of 2. That is, I want the two values to be interchanged. So to do that, I create a function called void swap, and then I declare these two arguments. And then what I do is I declare a third variable inside it, of type integer, int t, and then I pass the value of x. Then I pass the value of y to x, and then in y I end up passing the value of t. So what will happen is if x is 2 and then y is 3, t ends up getting the value of 2, um, then x ends up getting the value of 3, and then y ends up getting the value stored in t, that is 2. So after swapping, you have these outputs. uh, you have the main function, you declare x as 1, y as 2. Before swapping, you just you print the values before and after swapping. So before the swapping, x is 1 and y is 2, and then you call upon the swap function. So the swap function is this, where the values are interchanged, and then it says after swapping in function x is equal to 2 and then y is equal to 1. So you can see that the values have been interchanged. But then you have the last two lines of the code which says after swapping, and then you try to print the value of x and y over here. But then when you do that, x still remains 1 and then y still remains 2. Now, the reason for that is when you use call by value, what you're doing is you're not actually doing anything with reference to the variables. Uh, when you talk about platform dependent programming languages like C and C++, you need to understand that memory is everything. So when I say something like int x is equal to 2, I'm saying that x is basically a variable of type integer. So in C++, as we saw before, integer occupies 4 bytes. So what's going to happen is when I declare in a program that int x is equal to 2, it's actually going to allocate about 4 bytes worth of memory, um, 4 bytes of memory to a variable called x, and then it will store the value of 2 in it. And similarly, when I declare int y is equal to 3, it will allocate 4 bytes in the memory to a variable called y, and then it will store the value of 3 in it. So that's how the memory allocation works. So when I use call by value, what I'm doing is I'm declaring a function void swap, and then I'm saying int x, int y, and then I'm passing these values in here. So what's happening is if if x if the if x, that is, if the portion in the memory that is dedicated to x has a value of 1, it'll just end up copying the value at the location and then pass 1 over here. And then when I say y over here, it will just copy the value in the location y, that is 2. And then within this function, those two values are swapped. So 1 gets swapped with 2 and 2 gets swapped with 1, but it's not actually doing anything to those to those different variables. So within the memory, if you're allocated x as 1 and y as 2, it just copies those values and then interchanges them. But it doesn't do anything to modify the actual values in those allocated locations. Those remain the same. So within the swap function, within the swap function, you're just passing the copies of the values, so they get interchanged. That's why when you say after swapping in function, you get the interchanged values 2 and 1. But here in this case, when you say after swapping, you're just trying to make it print the values in the actual locations, which do not get modified in call by value. So that's why it will still say 1 and 2. So that's what call by value means, where you just copy the value of the parameters instead of passing the values of the actual parameters. So one is an original copy and then the other is a function copy. So if you make any change within the function, that is this function where you're making a change, it's only modifying the copied values. It's not doing anything to the actual values in the location. That's what call by value means. The next one is call by reference. Now this is the method in which you will actually end up modifying the values in those locations. So again, you have int main function, you have a declared as 100, b declared as 200, and then when you try to print the values before the swap, a would be 100 and then b would be 200, and then you call upon the swap function. But then when you actually end up printing the values of the two variables, like the actual variables, you'll see that they get interchanged. So a becomes 100 and then b becomes 100 because this is how call by reference works. Uh, Sorry, when you call upon the swap function, you're not passing copies of the values of the variables. You end up passing the address of those variables. And then when you go to the function, you have these different pointers, and then you have temp, an integer variable temp. So when you say temp is equal to star x, you're not passing a copied value to the variable temp. You're saying that whatever value is stored at the location of x should be stored in temp. Then what? And then, when you say star x is equal to star y, you're saying that copy the value in the location y to the location x, or replace the value in location x with the value in location y. When you say star y is equal to temp, you're saying that the location of y should end up having the value of the temp variable. So here you're not copying the values of the parameters, you're passing in their addresses, and then you're interchanging the values stored in the location. So in this case, you actually end up modifying the original values. So you end up passing the address and not the value. So this is the difference between call by value versus call by reference, wherein one uses copied values of the parameter, that is call by value, whereas in call by reference you make it point to those specific locations of the parameters. And so when you make it point to those specific locations, you end up modifying the actual values within those locations. So that's what call by reference means. When you talk about C or C++ programming, you generally end up seeing call by value. Call by reference is something that mainly happens with a programming language like Java. But then, because this is an important concept, I did not want to leave it out. That's why I discussed it. And I think the time is almost up. So yeah, that was the presentation. Um, Let me see. Let me return to the call. Uh,
I'm gonna send a workshop link.
okay, wait. So, yeah, I think if anyone has any questions, I think there is time for maybe one question, because I think it's a little late there. Plus, even I have a commitment at 7. I'm in PST actually. So if there's any one question, please let me know. I'll just mute myself, and then if anyone has a question, they can unmute and speak up. Yeah, I see that you have sent. Oh, you're saying this is a workshop form. Okay, yeah, that's what I thought. It's probably for the participants. No, actually, because I asked if there are any questions. I thought this is something related to that. Does anyone have any questions? I can answer maybe a small question. Any doubts within what? Any doubts regarding whatever I presented? Okay, so